Hey guys, welcome back. Today we're going to be solving LeetCode number 7, reverse integer, which is an easy problem, and to be honest it was pretty easy. Feel free to pause the video to read through what the problem is asking for, but I'll just explain from the example. So given an integer like this 1, 2, 3, you want to return the reverse 3, 2, 1. It's that simple. And there's some keywords we were given here. First one is 32-bit integer. We need to make sure it's 32 bits. Okay. And the second is we can store 64-bit integers. So meaning if we go above this max, 2 to the 31 minus 1, we need to return 0 because we have a 32-bit system. Okay, this is the second constraint we're given, both for the negative bound and for the positive upper bound. So that being said, let's get our hands dirty and code it. Okay, so the first step to this is I want to take account for the negative cases, just in case we're given negatives. So I'm going to create a variable called temp, okay, and I'm going to assign him to the absolute value of our input x. Again, as always, we use Python 3 because we can. Okay, so first I create this, then next let me make sure this is okay. Good, 75 jump. Okay, then next I'm going to create a variable to hold my result. I'm going to call him, guess what, result. Set him to 0 for now. Okay, now let's iterate through our number. So while temp, I'm using temp again because we've converted him to a positive number. So while temp, as long as temp is not 0 or negative, like what do we want to do? So let's create a variable to keep track of our remainder. So a remainder is just going to be temp modulus temp. Okay, all this does, for example, let's go back to one of our example cases. In the case this, if you modulo this number 1, 2, 3 by 10, we just get this last guy 3, because 10 divided by this, the remainder is 0.3. So we get the remainder. Again, in the end, we're going to visualize the code and you guys are going to see what's going on. Okay, then we're going to, once we get this guy, we're going to see our result. It's just simply equal to our result, okay, previous result, multiply by 10, okay, plus the remainder we just calculated. Keep in mind, in the first iteration of this loop, our result is 0. Our remainder, again, if we're going to use the example 1, 2, 3, our remainder is going to be 3. So all we're doing here is 0 multiplied by 10 is 0 plus 3. That'll be 3. In the second iteration of this loop, our remainder is going to be 2, because then we've taken out this 3. Our remainder is going to be this 2. And all we're going to be doing is 3 times 10, 30, plus remainder 2. It's going to be 32, and it's going to keep doing it on and on, but you guys will see in the end. Okay, and then last but not the least, what do we want to do? We want to say temp is going to be equal to integer division by 10. Okay, again, we're going to visualize it and we're going to see. So this is literally all our algorithm. So now let's try to return our results, and here's the return. So we're going to say if our result, okay, if it's greater than, again, we were given the constraint of 2 to the power of 31. Okay, if it's greater than 2 to the power of 31, okay, what do we want to do? In this case, we just want to return 0 because that's the max our compiler can go. So elif in this case, so we want to check if our input was negative. If x was negative, which was the input we're given, if it's less than 0, we want to return -1 multiplied by results. Okay, that's why we created a temp variable to hold this. And then last but not the least, our else case, okay, meaning it's positive and it's lower than this upper bound, we just return results. So let's go ahead and run this code, see what's going on. Okay, accepted. Let's go ahead and submit it. Boom, submitted. 89%. This is pretty awesome. As always, we like to take it one step further. We like to visualize it. So this is the exact same code, but our example is -1, 2, 3. So we should expect a reversal of -3 to 1. So let's go ahead and visualize it and see what's going on. Okay, we declare our function and we call our function and pass it x. Okay, so in the first iteration we create temp. Temp is just the absolute value of x. So we just get rid of the negative sign. Okay, then we result variable 0. Okay, then our while loop. So while temp has some value, what do we want to do? First is create our remainder. Our remainder is just temp modulus 10, okay, which is 3. So we've captured this last guy now, 3. So next, our result is just previous result multiplied by 10 plus 3. So our result is just going to be 3 in the next. Okay, bam, our result is 3. Okay, so next temp, we're going to adjust temp by dividing him by 10. If you divide 123 by 10, it's just going to give you 12, because we're doing the integer division and getting rid of the remainder. Okay, so now temp is 12. So we do again the while loop one more time because it's 12 is not 0. Okay, so back in the while loop, our remainder this time is going to be 2, right? Because 12 divided by 10 modulus 10, I mean the remainder is 2. So boom, remainder is 2. So now result is previous results. Okay, result is previous result times 10 plus remainder. Previous result is 3. 3 times 10 is 30. 30 plus 2 is 32. So our results variable should get updated to 32. Bam, 32. And now our temp should go down to 1 because we'll divide this floor divide, integer divide this by 10. So temp should become 1. Okay, so it's still 1, so we want to capture the 1. So we're going to do it again. Okay, so our remainder this time is 1, right? Because 1 modulus 10 is just 1. Okay, so next our result got updated, and now we're gonna go out of our while loop and do our if check. Okay, he's less than the maximum, so that's good. He's negative, so we're gonna have to return our negative value. So that's it for this problem. I hope it was helpful, and I'll see you guys in the next one.